Hello, everyone. So I promise not to hold you back too long before lunch. I know I'm the last one beforehand. But I'd like to talk a little bit about bringing your app to life using a few different tools and technologies that I got a chance to use recently, such as CALayers, paintcode, and just tying it all together with core animation so that you can provide some really cool experiences in your app. You might be wondering, who is this guy? Well, my name's Steven. I'm a senior iOS developer at Fitbit out of Boston. But as my small spiel, we have an office in San Francisco, Boston, and Minsk. So if you're looking, we are definitely hiring. I've done a few things open source and et cetera, so you can find me at the usual spots. But moving on, I know that having the slides handy is convenient, so not only are they in the app, but you can access them from this bit.ly link, or if you're one of the few people that actually scans the QR code, it's conveniently located there. So I'll just wait a moment in case anyone wants to grab the slides. Now, unfortunately, I do not have any poems in my talk, any anecdotes, or a number of those things, but what I do have is a lot of pictures, videos, and code. So hopefully that will suffice. But to begin with, this all started when a couple of my colleagues worked on some sleep goal features. And they had some really fun ideas, and the designer Drew Matthews and developer Aiden Desart worked on this, which we like to call the Happy Moon screen. We used the little Happy Moon in a couple of places. One right here was just the introduction to sleep goals. Another place in the app was if you actually trigger tracking your sleep from the app. And it's just this really delightful screen that has this little happy smiling moon. And they did this by using paintcode, CALayers, and basic animations. It was a great case for this because if you look at it, it's actually really simple. It's a circle with a couple more circles and a few basic shapes. So when I had a chance to work on a new feature coming up, I worked with a couple of designers as well, and their thought that was we needed to spice it up and use what we had learned beforehand and see what we could come up with. So I had a chance to work on a feature for Fitbit called hourly activity and reminders to move. It tracks sedentary time, how often you move throughout the day, and also reminds you on your wrist whenever you're not moving. And we wanted to tell people what it was without being just another series of boring onboarding screens that you wanted to get rid of. Of course, in the top right, there's a done button in case you still want to really get rid of these. But maybe with a little bit of fun illustration to go with it, it could make it a little bit more active, and you could have some call to actions at the end to actually adjust the experience. So this is actually a recording of what you can get into the app right now, and maybe some of you have actually seen this. But this was actually first started by a designer who gave me a rendering of a video. They used After Effects and some illustrations, and they put together a preview of the animations that they wanted in the app. The actual video itself looked very much like this, and so we had one of the key things is having reference when you're dealing with animations. You can tweak things so many different ways, and as a developer, I find it extremely helpful if you have someone on your team that's skilled enough in After Effects or a number of other different tools to give you a preview. So the first question is, of course, how do we build this? Well, the way that I decided to build this was to flesh out what we had done before. So a couple of different stages of the pipeline. First, you start with Sketch for vector illustrations. You can do Illustrator, Photoshop, anything that your current asset pipeline works with, but it should probably export SVG. After that, you go with paintcode, which we'll go into depth a little bit more. It's a tool set, a third-party tool for actually rendering these illustrations and producing code in Objective-C or Swift so that you don't need assets, and then you can actually move and adjust your assets as you choose. And last, we'll do all the actual coding part in Xcode. So to start off with Sketch, at the time, they didn't have a plugin for, paintcode did not have a plugin for Sketch, but now they do. It's really cool. I'm still going to cover using the actual paintcode GUI, or user interface, because I find it actually fairly intuitive and I like it a lot, but there are options for just using their Sketch plugin. But first, we have to start with our assets. So right here, I have just one of the assets for our illustrations that our illustrator put together. And in the bottom right, in Sketch, you can make something exportable. Well, if you select that and actually make your format SVG, typically if you're used to ever exporting things from Sketch, then you're used to doing several different PNG exports at different resolutions. Well, if you do SVG, it's a standard vector graphics output, and you can take that directly into paintcode. So we're going to cover paintcode just a bit. It has some definite pros. One is that it's vector output, not raster. So if your screen size changes, you still get pixel perfect rendering. It's performant because there's no assets. It's all drawing based. It's easily adjustable, so it has a what you see is what you get, or WYSIWYG if you want to sound crazy. It has a easily adjustable editor I found very intuitive, and it's got some really handy tools such as anchor points, relative locations, transformations, and you can apply this to multiple different areas of your illustration. And the last thing is that it outputs standard iOS code. So you can take the code from paintcode, put it into your app, and people can come back later and read it. Now, some of the cons. It's great for controls or things that run continuously or things that are not an iterative sequence. Well, unfortunately, our animations are actually sequential. So we're going to do a little bit of adjusting to work around that. Because it relies mainly, by default, off of draw rect. So just every time that your view needs to draw itself, paintcode will output code that goes inside of there and actually just draws itself based upon that current frame. Of course, another thing is that it imposes a third-party tool for actually updating your UI. So everyone that needs to work on this needs a license to paintcode. It's something that's outside of your Git check-in, possibly, or in another asset location. So it's just another dependency. You need to be cautious before you go down that rabbit hole of do you want to do this, because you are adding another dependency to your code base. And one of the things that I found in hindsight is actually that you can have some possible small compile time increases. I've seen with highly complex illustrations such as these that you can spend a few more seconds on the compiler actually compiling each one of your custom views. You wouldn't have that if you had assets. But on the other side, it decreases the size of your bundle because you don't have assets. You are not possibly leaking pre-release information. All sorts of other benefits for not having assets. So one of the first things you can do with paintcode is you can group all of these different vectors. So this is just an example. I've grouped a couple of things into a chair, a body group for the person. The body group can have subgroups, left arm and right arm, etc., and it allows you to work with things as opposed to a whole bunch of different vectors as groups. It seems logical, right? Another thing is variables. It's kind of hard to read because the screenshot's rather small, but you can take these groups and drag them and drop them and create variables and allow you to actually apply transforms in your paintcode editor and see what happens just based off of that, to that whole group. So in this case, we have the right arm. We can make that into a group. We can create a variable called right arm angle and actually adjust that in our draw rect function if we were using that, or in some other way later on down the road. And here, for example, is just some example of what we actually get from paintcode. We won't go over this too much because we're going to modify as we go, but what it does is it's draw intro scene with frame. So you take a frame. In this case, I have one variable. It's that right arm angle. And then it goes through and actually just programmatically draws all of our vectors. This is an example from their website of what paintcode is really good at. So there's a bunch of different variables and arguments, and you can tweak them, and they adjust all of these different controls and vectors in our scene. So you can adjust the radius, the angle, etc., and it's all real time. It's very cool. But as I mentioned earlier, this isn't exactly what we want to do, so we're going to do some tweaking. And that brings us to CALayers. So instead of using a draw rect, I'd like to actually break down our groups into custom CALayers. But first, let's rewind a little bit, because getting our assets through our pipeline actually involves a little bit of work, it turns out. The first thing is that you're going to want to clean up your vectors likely. So if your Illustrator gives you a file where it's just, in this case, I have fireworks, and each one of those is another vector. If they're not grouped together, it's going to be, the code that you get from paintcode is going to be very difficult to work with. So a few 5-10 minutes in either Sketch or paintcode, grouping them together, naming them a logical name in your GUI will save you a lot of time. You can do this by deleting unused shapes. Maybe another thing in vector files is you might find that there are shapes behind opaque objects that aren't being used. Well, I don't want to render that. That's just more time it takes, so I can delete those. You can merge continuous shapes into one shape. And then another thing I recommend is naming your colors and your layers, because later on when you get the code from paintcode, it'll take the things that you've named your groups, your layers and your colors, and use that in code. So it makes the code that you get from paintcode just a little bit more readable, which you'll really appreciate later on when you're trying to go through and understand what's going on. And there's just some really easy tools to do this. On the left you have Sketch, on the right you have paintcode. You can do it in either tool, either via before you've exported to SVG or after. And they both have the same tool set for doing union, subtract, intersect, and difference. Typically, you're just going to be selecting different vectors and applying a union to them. So the way we're going to do this is we're going to make our own custom view, and it's going to have its own custom CA layer. And this custom CA layer exposes different animatable groups. And the other thing we have to do is we have to manipulate our paintcode output, which is currently based on draw rect, to work with CA layers. So as an example, that first onboarding screen, the blue one we've been looking at, here's an example of our custom CA layer. I'm going to call it the onboarding layer. And it has a couple of different subgroups. And each one of these is a CA shape layer, or a core animation shape layer. We have our picture frame, chair, body, anything that I need to move independently of one another. Notice I have a left arm, a right arm, and a body, because I want to move each one of those independently. But also one of the other things we'll get to is that the arms are attached to the body. Now in paintcode you have bounds, anchors, and positions, and we'll be using those as we modify our code. But it's really handy because right here we have a screenshot of the right pane of paintcode. It gives you a preview of these different properties. For example, anchors, positions, and rotations are very helpful. By default, CA layers and also in paintcode, your groups rotate around the center. But for our arms, we want those to animate around the shoulder, or else our vectors are going to mess up. So what you can do is you can actually drag in your editor the little green cross down to where you want it to rotate. And now whenever you apply these translations, it'll rotate around that green cross. It will also give you in the right pane the information about where how this affects your bounds and your anchor point, etc. Now one thing about this process is that it's kind of annoying, but when you need to output code from paintcode, I found that you needed to break up your groups because of what we're going to do to it. And the reason you need to do that is that the draw rect will offset from groups into sub-layers. But in our case, we don't want a lot of those offsets in our CA layers. We're going to do that ourselves. So just for now, when you're done with configuring everything, break up your groups, and then you can export your code from that. So we're going to take the paintcode code, or paintcode output, if you will, and we're going to create a CA layer for each shape. That's one of the many reasons that we want to condense our shapes, because this is a little bit of manual effort. We're going to set the path of our CA layer to the output of what our typically what our Bezier curve of paintcode output is. We're going to place, before it would apply just fill because it's doing draw rect. Instead of just fill, we're going to do the fill color of our CA layer. And then we're going to add that CA layer to our parent layer. So let's have a look. So this is our initialization of that custom CA layer from earlier. And you'll notice that before we initialize ourselves, we're going to create our picture frame sublayer, that CA shape layer, if you will. And we'll create our picture frame. We'll set its anchor point, its bounds, and its position. Now, this information comes directly from paintcode in that right pane. So anchor point is going to be where it rotates around. Bounds is going to be the actual size, and position is obviously position. And then we're going to set the bounds of our custom CA layer as well, and that's, again, going to come from paintcode. And then we're going to add each one of our custom CA shape layers to our parent layer. So what does that create picture frame layer look like? So in our code that we got from paintcode, it actually comments for you with the name of the group, where it's rendering each thing. So we're going to take that, and we're going to put it into a method to just create each one of those subgroups. Then we're going to modify it a little bit, just like we mentioned. So I'm going to create a shape layer. I'm going to set any colors, or I'm going to create any colors with this picture background blue that comes from paintcode. And then I'm going to set the Bezier path to our CA shape layer path. So this is what determines what our shape layer is going to draw. I'm going to set its fill color. That determines how it's going to show up. And then we're going to add it to the CA shape layer that we're returning. Because this picture frame layer, for example, with those, the ellipsis there, we're going to do this for every shape in that picture frame output, which could be many of them depending upon what's in that little picture frame illustration. This can be a little bit time intensive, and in hindsight, the next time that I do this, I'd like to try some form of scripting or automation, but for the first iteration, it worked out fairly well. It didn't take too long. It was just something the developer inside of you really wants to try and optimize for. So where did that come from? Well, in the bottom section of paintcode, there's this output, and this is just an example, but for example, it does the picture background drawing and creates a Bezier path. It sets the fill and the path, etc. So we're going to take that out and just modify it like we just did. Now, I mentioned earlier, if you don't break up your groups, this is just an example of what we don't want, but normally it will do these offsets. So CG context, translate, and rotate, and put those into the actual stack. We don't want those considered because we're actually going to CA layers as opposed to just this iterative drawing code. So that's the first part of this. This is kind of the hard, boring part. We want to put this all together and get it isolated so we can add animations and translations, et cetera. And it involves a lot of rinsing and repeating. As you notice, there are a bunch of different illustrations, breaking them down, creating custom CA layers. But what we end up with is, on the left, I have some of the different groups highlighted. So we have like a body group, different arm groups, chair, lamp, et cetera. And then when we render it out, well, we have a non-moving, perfectly illustrated thing that will look just the same as if I took an image and put it in there. So I just spent a whole lot of time doing something that doesn't give me very much until I get to the fun part. Now that we have everything broken out, it makes it really easy to use a bunch of different tools to play around. So the first that we'll talk about is CA transactions, or core animation transactions. And we're going to start with this first screen. Now you notice that one of the primary things that happens is that the picture frame, the chair, and the person come in from the left, and the lamp and that table come in from the right, and they meet in the center. So what we're going to do is we're going to adjust their position of the CA layer, of each one of those subgroups before we do anything, and move them off to the side. So I have this method here in my UI view. So this UI view would embed my custom CA layer. And it's got a hard-coded onboarding intro and animation offset. or sorry, not hard-coded. It's got an animation offset, and I'm going to take the width of my view, divide it in two, and use that as my animation offset. It's going to move them off to the side because they're centered. And then I'm going to call this little method called update position. It just updates that position property on my CA layer. And I'm going to set the CG point to negative that value. And this is before it's rendered, so everything will start off screen. Similarly, for the picture frame, we need to set its introductory rotation as well. So if we look at our animation, we'll notice that picture frame, as it comes in, it's actually tilted. It gives it a little bit of feel of movement. So if I set my rotation, in this case to 20 degrees, and then those arms as well to a certain animation, then later on when they get to the center, we can animate them as well. So this is where CA transactions come in. When we want to begin the animation, you can just say CA transaction begin, and then you can set properties on your transaction. In this case, we want the duration to be half a second. And then you can do timing functions just like you can do with a UI view animation or any other core animation based thing. So in this case, we want to ease in and we also want to ease out. You can play around with those really easily. It's a lot of fun. And it just uses some constant string naming, unfortunately. No enums, et cetera, because the Objective-C is still strings. And then all we have to do is just set the position property on those layers that we just did before and commit our transaction. The commit will actually cause this to happen. And begin and commit, anything you put in between there, chunks them all together, just like begin in animations on a table view, et cetera. So in this case, we're going to update the chair, the picture frame position, all the other things that we've modified, and put them back where they were. And when we commit, we're going to get that nice animation. It's going to move them from the outside directly into the inside. So here's another big chunk of code, though. What if we want to animate that picture frame? So that picture frame, if we look at it, it's got a little bit of a wobble on it. So it moves in from the side, it's angled, and then it wobbles at the end. So we can use core animation basic animations for this, and a subclass of that is keyframe animations. So I got this lazy variable called picture frame animation that I can construct. And it's a whole lot of code there, but it's not too complicated. It mainly creates a keyframe animation and sets a bunch of properties on it. So it does things like set the key path. And that's one of the more important things. We're going to set the key path to transform.rotation. And in fact, I think I have a typo in there. It says rotation. Rotation. And this uses a key path on the object that it's applied to decide what it's going to animate. In this case, we want our key path animation to work on that rotation. And the reason we use a keyframe animation, and the reason we use keyframes is that we want multiple things to happen that are iterative steps. So you notice we have a values array. The values, I'm going to put the angles that I want that picture frame to be. Well, if we look at our animation, it kind of wobbles a little bit, but that's just the angles that I want to be in different states. So it turns out it's 0, -30, -10, -20. That series gives us that animation. And the animation overall is going to take about 1/3 of a second. The duration is 0.75. And the other key thing is that we have these key times. Now, the key times for a keyframe animation are at what point do each of the values occur. So in this case, every third of the animation they apply, but you can change those however you want. It's usually just within a range of 1. And so if I said something different, it would happen really quickly, and then maybe wait, and then happen quickly again. In this case, we want them evenly. But you notice that there's a timing functions in there as well. So each animation in our keyframe, optionally, can have its own easing type of animation curve. You don't have to do this, but in my case, I found with the little picture frame animation, if I didn't customize those animation functions, it looked a little bit stagnant. That linear animation curve kind of drains a little bit of the life out of your animations, particularly if you use keyframes, because you have multiple things happening in succession and you want them to feel like they flow into each other. So this thing right here creates a CA animation, which it creates a keyframe animation, which is a subclass of CA animation. So as far as any caller knows, this is just some form of generic core animation. So we return that, and we apply it to our picture frame, which I think I'll cover in just a bit, and we get this nice animation in the beginning where it actually comes in and wobbles a little bit. So how do we actually add these animations? Let's talk about the arms for a moment. So the arms actually do the same thing. They come in kind of at a 90-degree angle, and then they come up top, but they also have a little bit of a bounce to them. We can do the bounce similarly. So the way that you add animations, really simple. I take my CA shape layer, left arm, right arm, picture frame, and I just call it add animation. It's adding my core animation, basic animation there, and then you give it a key to identify it. You don't actually have to give a key, but if you ever want to find this animation later, that's the name of it. I also recommend it for debugging, and give it something uniquely identifiable. Now here's another one that's actually very similar to our picture frame for our arms, and this is a base property or method for creating arm animations, because my left arm and my right arm do almost the same thing, except they're inverse of each other. So I create another keyframe animation. And one key thing to look at right here is actually the begin time property. So in both the arms and the picture frame, we don't want them immediately animating. You can actually set a begin time that's offset from whenever it's triggered using CA, current media time, and then you add in the delay. So this is going to happen a quarter of a second after I ask it to. And the rest of it is exactly the same as the picture frame, except we have just one less value in there. It's just going to animate a little bit, have a little less complexity. So I'm going to call this arm animation to fill out my left arm and my right arm. So my left arm animation is going to call the arm animation. It's going to set the values because the values are different for the left and the right arm because one is on the left and one is on the right, and they both have different angles. I'm going to set the key times and then return that. And this left arm animation, if we remember, is what we used right here to add that to our CA layer. And whenever you add the basic animation, it's going to trigger immediately, actually. So just by calling add animation, it's going to add the animation onto the layer and trigger. And voila, we have our intro animation. So let's move on to animation groups. So in our third screen, we have these fireworks. And the fireworks have a couple of things happening to them, actually. And I can't use keyframe animations for these. If you notice, they get a little bit bigger, but they also fade out. In that case, I want multiple animations happening on these, essentially. So I can do an animation group. So we have a large firework animation group. I want to repeat essentially forever. So you can set a repeat count. And then I can set multiple basic core animations on my animation group, and that's how it works. So on this one, I have an identity transform animation and a fade animation. The identity one is one that I create. Both of these are two different animations that I have extensions for, and they create some basic animations. Identity, in most of the time for graphics, is return to your natural state. So in this case, we shrink our fireworks down, and then we put an animation for them to return back to their normal size. And then we have the fade animation happen after that. You'll see that in the configure firework animation, we get this group. We set the duration for the group. So the whole thing is going to take 3.5 seconds, and then it's going to repeat itself. That allows us to do our two animations in our group, and then let it wait a little bit, and then repeat over and over again. And you'll notice we call the same thing add animation. That works just like our CA basic animations. And now we have large fireworks that grow bigger. They fade out a little bit, and then after 3.5 seconds, it repeats over and over again. But we still have a few more tools to explore so that we can make all of our animations just how our designer asked. So let's go into CA transactions a little bit more. So in this animation, you'll notice as our person comes on screen, after they get to the center point, only then do we move their arms and their leg. So they come in like they're running, and then when they get to the center point, they move. Well, what we want is actually a completion block. So before, for our first person, we were animating as it came on. But in this case, after we move things to the center, only then do we do our animation. So if you remember before, we use a CA transaction for that. So we're going to begin, set our duration, set our timing function, basic things. And then you set a completion block. Really simple API. So we can set a completion block and set another CA transaction to occur after the first one has. So our second CA transaction is just going to take our left arm, our right arm, and the left leg subgroups in our CA layer and set their transform back to identity, aka back to their normal state. What we'll do is, before this is ever called, we'll actually rotate them out a little bit, and then whenever this is called, it rotates them back in. And it works just like our other CA transaction. So you set its duration and anything else, and you call commit. When we're done setting up our completion block, we can do any animations we wanted in the outer one. One of the key things, though, is that you want to set your completion block before you commit your CA transaction. Because if you commit your CA transaction, it doesn't have time to apply that completion block. It has to be beforehand, so that it knows that it's there before it actually initializes the animation. In this case, we're going to do the similar thing to before. We're going to move things to the center. So we get our outer animation, where the character's body moves to the center, and then when that's complete, we rotate the left arm, the right arm, the left leg. So one last thing as a bonus is CA transitions. These aren't core animation for CALayers, but they are a fun and easy tool for making things look nicer. In this case, you'll notice our onboarding, the text fades between itself. It's a much nicer effect than if you just take text and do for your UI label and just say set text. Because it'll just take the text, and one frame it'll be one thing, and the next frame it'll be another. It's very jarring, especially if you're fading between colors and everything else around it. Now here's a simple extension on CA transition that's a factory method, if you will. It just returns a simple fade CA transition. So a CA transition can be applied to something like a UI label. In this case, we set its duration. We set its type. There's a couple of different transition types and a timing function. In this case, we want to do the ease in, ease out. It's a very nice timing function for most things. And then we want it to be removed whenever it's done. And that's it. So now, if I ever want to fade between text when I'm adding it, I just say, okay, we'll give him my UI label, get its CA layer, add an animation for my simple fade transition that I just constructed for a key. And whenever I do that, I get this nice animation in between text. So wrapping up, you'll note that the first half of the talk was all about our asset pipeline. No matter what you want to do, it depends on how your designer's working, if you're doing it yourself as an indie, to figure out what your asset pipeline is to get your assets into a state where it's easily animatable. Use whatever works for you. In this case, I found that Sketch into paintcode worked well, but maybe something else works well for you. You can combine core animations, such as basic animations, keyframe animations, animation groups, and then you can also do things like chaining transactions together. So if you need things to happen in a sequence, moving objects, rotating them, you can do completion blocks and chain them together. And lastly, as we saw, CA transitions are very simple, and they're very effective. You can put a transition on most any label, and it looks much nicer when you're setting the text. Think about it next time that you just do set text if you want to actually fade in between them. So that's it from me. Does anyone have any questions?
Thank you very much. All right, I see 2 questions. All right, one here. Yeah.
Hi there. Thanks for the talk. It was really great. I had one question, and how did your development setup work? Did you use a separate project to build these animations, and you build and run it all the time, or did you use playgrounds or something like this?
That's a good question. So the workflow worked. So I had paintcode off to the side, and I took my assets and put that into paintcode. At the same time, a designer took After Effects and did a lot of the playing around with what they wanted the animations to look like. And they rendered out a video that looked pretty much like you just saw. So that saved me a lot of time because I didn't have to do a ton of playing around to figure out even what looks good. But after that, and you get everything set up into different layers, at the time, I was actually writing Objective-C, so no playgrounds, unfortunately. And I was building and running frequently, but it wasn't too slow of a process because you can tweak some values. Another thing that you could do is you could actually pause, tweak your actual CALayer properties or some of those values and continue running. But I honestly didn't find that it was too slow of an iterative process. You could also add controls in there if you really wanted to tweak things. But for this case, I didn't feel that those were needed.
Okay, I see. Thank you.
Another question over here? Yeah. Or
Hi, thanks for the talk. Did you have some problems when going to background with the application that animations kind of get stopped in a...
Yes, so that's a good point. So one of the key things for core animation and CA basic animations is that when your view disappears, they can be removed. So in particular, the fireworks screen, the fireworks would stop animating if you put it into the background and came back. One of the things to get around to work with that is that when your view will appear, you can apply your animations. When it disappears, you can remove them. That's why naming them can be appropriate as well, because you can find the animation. It also does not matter if you tweak that property, remove on completion. Even if it's don't remove on completion, when your view will disappear, it will be removed. That's one of the, because most of the time when you're looking at documentation, Stack Overflow, et cetera, the first answer is, oh, we'll just set remove on completion to false, which works about 99% of the time until they put it in the background and bring it back, or maybe a modal presents over the top. That was another case, because your view will disappear. So it's a really good point. Keep that in mind and try to work around, make sure that your animation state works whenever you put the app in the background and bring it back. Sometimes you might have to consider removing your animation when it's completed and reapplying it when needed.
And one more question, or like if you have different screen sizes or maybe an adaptive layout, have you found a way to like adjust the sizes to?
Yeah, so for this one, it does work with different screen sizes and can work with a larger or smaller, but in that case it was because you can adjust your vector output to be smaller and scale appropriately so that your empty areas scale appropriately. But the nice part about paintcode, at least, is that it's a vector output. So it can scale as you see fit. However, in this case, because it works really well in the draw rect function, it scales. But when you convert it into a CA layer, it doesn't, because your CA layer has a bounds. But if you adjust your CA layers to have a different bounds when you change the size of your layout and then readjust your path, you can do that. In this case, I didn't need to worry too much about too many different sizes. I decided to make the illustration smaller and the rest of the content expand around it because it still looked very nice. And in one case, for example, any of the ones with buildings, the buildings actually go out to the side as well. So if it's a landscape, the buildings keep going. But if you need to adjust the vector output, you can actually make a subclass of CALayer or UI view. No, CALayer, and then when you adjust the bounds on your CALayer, you'll need to rebuild the path. And it can be a little bit expensive in this case because we have a lot of different or at least many different CALayers. So resetting the path every time that the bounds change could be somewhat expensive, but if you're only doing it on rotation or changes in view size, it wouldn't be too bad as well.
Yeah, just one more remark. I have made the experience that it can be like also quite nice if you use UI views instead of layers.
Okay.
And you can use auto layout for kind of laying out your final position of everything. And then like when you resize, each of the views will like kind of figure out how it's supposed to be. And yeah, you can use the draw rect type, for example, to adjust. Yeah.
Mm-hmm. Yeah, in this case, CALayers were helpful because you can also do particle effects and a few other things that you only get with CALayers. So, for example, the clouds. We didn't get into this, but there's a particle emitter that emits CALayers as particles for the smaller stars and some of the clouds. So I kept it all CALayers, but UI views still do a lot of the same. You still have access to a lot of the same things as well.
Thanks.
All right. Thank you very much. We're running a little bit out of time. I'm sorry, we have only 65.
You can come find me afterwards.
Yeah. You can just grab Stefan afterwards. I'm very sorry, because we only have like 65 minutes for lunch break. Okay, guys, thank you very much again.
Thank you.